All right, so right now we're going to be doing the problem, return the last node in a cycle. So similar to the problem I did yesterday, what's going on here is you are given a linked list, right? These nodes are equal to the next node and so on. And our first thing we're going to do is check if it's a cycle, right? If it's not a cycle, we're going to return false. If it is a cycle, then the main goal is to return the last node, right? So now as we kind of have an idea what we need to do, the first step is we need to check if it's a cycle or not, right? So we're given this class up here, which is connects nodes, and then the main thing we were given is just an empty function, which passes in a head, right? So the first thing we have to do is kind of use the slow and fast technique to check if there's a cycle going on. This is exactly what we did yesterday, where we're going to go and create two variables, set them both equal to head, right? Because we're starting at the same position. One is going to go with the normal speed, while the second one is going to go 2 times the speed, right? And then what you're going to do is you're going to do, well, fast and fast.next. The reason why we do this is because fast is going 2 times the speed, so we need to make sure that the .next value, there's space for it to land on, right? We're going to do slow equals slow.next, right? And fast is going to equal fast.next. Next, I mean, my bad. There you go. All right. So if slow equals fast, we're going to want to break this, right? Because that means that there is a cycle and we can continue on. If not, then we just want to return false, right? So this whole section here is basically just checking if there is a cycle or not. Perfect. All right. And this is the first step. Now the second step is basically going to grab the start of the cycle, right? So using Floyd's algorithm, what's happening is slow and fast here, when they meet up at a specific value. It's random, we don't necessarily know, right? However, um, meeting at that point, it's not specifically at the head anymore. So what we're going to do is we're first going to set slow equal to head again, right? Because we're going to need, we are going to need a variable to start at head, right? And we're going to leave fast as it is, right? Fast is currently equal to where these numbers met. And then what we're going to do is while slow doesn't equal fast, we are going to iterate. So slow equals slow.next and fast equals fast.next. So instead of doing .next, iterating 2 times speed, we're just going the normal speed, right? And what's going to happen is that slow gradually over time is going to set equal to the beginning of the cycle. So to kind of show that in a sense, right? Let's say fast is at index 4, right? And it's there from this section of the code, right? So we're going to leave this here, and theoretically, slow and fast would have been at the same spot, right? However, we set slow equal to head again, right? So slow is back to here. So what's going to happen is we're going to iterate once, right? .next for both of them. So if 4 in the linked list goes back to node 2, right, because it's a cycle, then once this iterates, it goes back to here, and slow moves 1, and they're now back on top of one another, right? This will always happen due to Floyd's algorithm. So because now they're on top of one another, we now know, okay, so the start is 2, right? So if we have the start, all we need to do is just iterate, right? Okay, so start.next, and we need to check if the value after the value we're currently on is not equal to the start, then we just want to return, because remember, we want to output 4, and 4 is the number right before we hit 2, because 4 goes back to 2, right? right here, node 4. The next value after node 4 is node 2. So we want to bring node 4. So that may sound a little bit confusing, but what's going to basically happen is now we want to basically the last step, grab the last node, right? So what we're going to do is we're going to set a variable. We could do cycle underscore start equals slow. I like to do this because it helps me, look at the code more easily. And then with that, we're going to do okay. Cycle underscore start equals slow. Yeah, no, we could just do it. Okay, so while cycle underscore start dot next does not. Oh, actually, no. Cycle dot start equals start and current equals cycle dot start. There you go. Okay. So this is the value, right? We do not want to reach, right? There you go. So while current dot next is not equal to cycle underscore start, right? We want to do current equals current dot next, right? Perfect. And then this is going to continue looping until we basically hit 4, right? And once we are at 4, the next value will be 2, right? Because remember, we set cycle start to 2, right? We don't want to reach the start of the next cycle. We want to kind of being inside the cycle, right? Once it's equal to the next, right? Once it's equal to the start of the cycle, we know, okay, the cycle's ending and the value we're on right now is the last one. So then with this, all we need to do is just return current dot value, right? Perfect. I think everything looks good here. And all we need to do is just initiate this function, find underscore last underscore node. We're going to pass in node 1. Then we can just print test. There you go. And we return 4, right? Beautiful. So that's how you do that question. With this question kind of dips in, I would assume we work with linked lists. We use this last fast and slow technique, and then we also use a technique called grabbing. What that technique kind of does is we is instead of like working on one particular function, what you could really do is kind of break these into multiple functions that mess around with the linked list, and that's kind of what that technique does, is where you create multiple functions or multiple in this instance, instead of functions, like just multiple sections of code which messes with these linked lists in order to kind of get the output that we're trying to best achieve.